Good morning. So we will start graphing parabolas, graphing quadratics by intercepts, solutions, roots, zeros. So today we'll focus on factoring, and then I'll shoot another video that will just specifically be on graphing by square roots, graphing by the quadratic formula, and then graphing by completing the square. So I'll have the videos separated so that you can also practice solving the quadratics by those means. Okay, so here we go. All right, we're going to graph the quadratics by intercepts, zeros, roots, solutions. They mean the same thing depending on your directions. Intercepts, in this case, they're x-intercepts. You learned about it when you were graphing linear equations. And then zeros, roots, solutions, those are a bit more, those terms are new to you. Next year in IM3, it's a huge part of the class with your graphing, okay? So this is essential. All right, here we go. Oh wait, I turned off the lamp. Oops. Okay, we're gonna factor, then graph. So if you notice, I left all the prompts out that you're accustomed to, where what's the A value, concave up or down, positive or negative, what's your vertical horizontal shift. We'll get to those because after I cover all of these, then I'll give you a mixture assignment of just complete graphing everything. And then I think I'll have a test available that if you want to give it a shot and see how you do, and if you do poorly, then, I just don't count it. But if you just want some feedback on how you would do, if, say, we were still in class going at a normal pace, okay? So here we go. We're going to factor, then we're going to graph. The XY table, you'll see how this lays out. I gave a lot of space. We're going to make this increment by 2s because you're going to go really far because there's a negative 24 here. Okay, so let's graph. But factor first. Okay, so we're going to factor this. So we're not doing that minus b over 2a, which is standard form. Remember, we are doing this by factoring first. So you have to show that work. Okay, so if we factor, this is a, b, c, right? So here's my a value, here's my b value, here's my c value, right? Because a is equal to 1, this is the easy factoring, correct? So no 8 times c, this is the easy one. All right, so magic x. My b value is positive 2. My c value is negative 8. So what two numbers multiply to 8? They give me the product 8. 1 and 8 and 2 and 4. Okay, so 8 is negative. So because 8 is negative, I know one number will be positive and one will be negative, and it doesn't matter which one goes where, right? Okay. But I want positive 2 as a summation or the difference. Now, because 1 is positive and 1 is negative, I know I'm going to subtract these numbers. So 1 take away 8 is 7, so that's out. And 2 take away 4 is 2. So this is our, this is our winner. All right, but because 4 is positive, that tells me the bigger number will be positive, the smaller number will be negative. Okay, so these are your factors. So if I asked you to factor this quadratic, you would give me y is equal to x plus 4, x minus 2, right? But because we factored here, this is 0, right? Because we factored it. Okay, now I'm going to take the 0 because we're going to perform the zero product properties, which is solving. Okay, so this is factored, right? This is factored form, but if I ask you to solve it, right, we let y equal 0 because we're going to find the x-intercept, right? How do you find an intercept? Well, if I want the x-intercept, then I let y equal 0, correct? Okay, so zero product property. If I set each of these binomial factors equal to 0, I get x is equal to negative 4 and positive 2. Okay, those are 2 points. So these numbers, I got them because I let y equal 0. Remember, the way you find an x-intercept is you let y equal 0, and then you just solve for this variable x. So yes, it was y here. I factored it. I got y equal, and here are my factors, right? My binomial product. I went ahead with the zero product property, so I let y equal 0. Perform the zero product property, so x plus 4 equals 0, x minus 2 equals 0. So that's why y turned to 0. So these numbers are my intercepts, my x-intercepts, they're my zeros, they're my roots, they're my solutions. Okay, so they're just not two numbers, they're actually very important numbers. So that means that when y is 0, x is negative 4. When y is 0, x is positive 2. So I'm going to put that here. When y is 0, I get negative 4 and positive 2 here. Now, it's not my vertex, so I didn't place it in the third slot. We have to find this point. Okay, so I'm going to go ahead and plot these two numbers here. So x is negative 4. Whoops, I was going positive 4. That's terrible. Okay, negative 1, negative 2, negative 3, negative 4. There's my point. Positive 2, positive 1, positive 2. Here's my point. So when you factor, and then when you perform the zero product property, it is because the directions tell you to solve the quadratic. Solve the quadratic. Those values that you get when you complete the square, solve by square roots, factor, quadratic formula, those values are points that the vertex has. Okay, now those points are very special because they're the points that are on the x-axis. They are your x-intercepts, your zeros, your roots, your solutions. Okay, so now what am I supposed to do with these? Well, you know vertices have symmetry, right? That the vertex in your axis of symmetry is at the halfway mark between these two, right? So remember, your axis of symmetry is a vertical dashed line that cuts between the two parts of the parabola. So find the halfway mark. If I'm at negative 4 and I'm at 2, remember equidistant. Find the halfway point. Where is that number? Okay, well, go evenly. If this one suits you, I might have to do it again. That's why I'm like, let's do it this really quick. Here, let's just use a Post-it right now. Okay. So let's use this. Okay, so this is negative 4. This is positive 2. Here's my line, right? All right, so here's, whoops, I should have gone here. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2. Right, negative 1, negative 2, negative 3, negative 4. Okay, if you move it, I would go 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, and you land right here at this number. And so if this is 0, this is negative 1. So this is negative, whoops, you can't even see. This is negative 1. So the halfway mark between negative 4 and positive 2 is 3 units in. 1, 2, 3, and then go again. 1, 2, 3. So if you count to the left and if you count to the right, you will get the halfway number, the halfway increment, the halfway mark. Because remember, it has every 2 points have to be equidistant, and those two, when you factor a quadratic formula or complete the square, the two values that you get are equidistant from each other. So if they're equidistant from each other, find the halfway, and that is where your axis of symmetry is. So if I were to do this again, right? If this is negative 4 and this is positive 2 and this is negative 1, 3 units away, 3 units away. And there is your axis of symmetry, and that is the x value to your vertex. You guys, so you're going to go 3 units in, 3 units in. Correct? Okay, so negative 1 is our axis of symmetry. Whoops, that is our dashed line. So here, -1 will be the x value for my vertex. So you can find this first or you can find this first. It's the same thing, right? It's that halfway mark. Okay, so if I won't move the post-it yet. So remember, our axis of symmetry is a dashed line that is running straight. I'll eventually move the post-it, but it is running straight through there. So when you factor, quadratic formula, complete the square, you find those two values, halfway mark, axis of symmetry, that's -1. That value is your x value to your vertex. Okay, so how do I find my y value? Your y value is you take this -1 input, you substitute it, and you get your output. Okay, so what do I get? So if I let x equal -1 and I take the parabola, I get, right? Okay, remember your order of operations. You are going to square first, right? Your work was really great with this, so I'm not worried about that. Okay, -1 squared is 1. 2 times -1 is -2 minus 8. And I just realized I'm really creeping in here. -1 minus -10 gives me -9. Okay, so I get -9. This is my vertex. So at -1, -9, I'm going to move this out of the way. I can do it one-handed. I don't think I can. Okay, so let's make this longer. I didn't close the door to here, to this room, so everybody was outside, but then they ended up coming inside, and I was like, whoops. But I don't want to pause this video because it'll stop it. Okay, -1, -2, -3, -4, -5, -6, -7, -8, -9. Let's count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so -1, right? So our vertex is -1, -9. And there's my vertex. Here are my vertices. Now, you can find two other points, right? I should have put these a little further away, but honestly, you essentially have your parabola. I mean, roundabout, this is a little far away. So if I was to plug in -2 and 0, right? So say -2 and 0, right? These two will be, they will have the same y value because look, if this is -1, -2 is 1 unit to the left and 0 is 1 unit to the right. Remember, equidistant, just like here, this 2 is 1, 2, 3 units away, 1, 2, 3 units away. So that's why we take the halfway mark to find our axes of symmetry. And then from there, we can easily find our vertex and then any other point. Okay, so we'll throw in 0 because that's easier. All right, so we're gonna let x equal 0 and I get y is equal to 0 squared plus 2, 0 minus 8, right? 0 squared plus 2. Okay, this is 0, this is 0, that's -8, so y is -8. Okay, 0, -8, I guess I maybe should have I could have gone a little further out to get more of the body, like here would be probably somewhere right here. Okay, and so now you connect, and there is your parabola. Okay, hey, that came out okay. Okay, and so here's our vertex, -1, -9. And again, I'm not going to have you do all those characteristics or those prompts in regard to these parabolas because I want you to focus on getting your vertex or axis of symmetry from your factoring. Okay, so I'll do this one, but it'll be a different video. So remember, we got our quadratic, it was given to us. We factored, we got our two factors. Okay, this you're awesome at. we perform the zero product property. So by that y value becomes a 0 because we're going to perform the zero product property because we're solving these two numbers, -4 and 2, are my x-intercepts. Remember, in order to find an x-intercept, you let y equal 0. And so that's why -4, 0, +2, 0, because in order to perform the zero product property, y became 0. So those are two separate points, -4, 0, 2, 0. Now 3 units in, because they are equidistant, that is where my axis of symmetry is located, x equal -1. My vertex is going to exist somewhere on this axis of symmetry. You have to find where the point is located. How do you find where the exact vertex location is? Take the value x equal -1, substitute it into the original quadratic. There's my work, input -1, output -9. I then chose 0 and -2 just to get a more accurate graph. So I just went 1 to the right, 1 to the left, which gave me 0 and -2. And when I inputted, where am I here? When I input x equals 0, 0, where x is, I got -8. And that's it. Okay, so let me shut it off and then I'll do the second one and then I'll give you an assignment. Okay, bye.